Okay, we're going to do a past paper question, which is on parametric integration. And this is a topic, at least in Edexcel, which doesn't actually have its own section in the textbook. I think it's mentioned in one of the worked examples, but this is a genuine past paper question, so it obviously can come up. You do need to know how to do parametric integration. So if you don't know, then you need to watch this video. Right, so there is just a formula for parametric integration, and I want to sort of show you how to remember it and how it makes sense. So obviously I have x and y in terms of t, and like not y in terms of x. That's why I know it's parametric. It also says parametric. I've got this region here. I want to find the area. So the usual formula for area, what I'd usually do would be able to say the area is the integral of y dx. Right, like say I had some curve and I want some area. I don't know, y equals x squared plus 2. And going from 1 to 4, something like that. So you say the area will be the integral from 1 to 4, x squared plus 2 dx. And this all works fine because what's inside my integral is in terms of x, and I have dx. So the dx needs to match what's inside. The x also matches this 1 and 4. These are actually values of x, right? I'm going from x equals 1 up here, all the way up to x equals 4. So if we try the same formula here, the area is going to be the integral of y dx. Then it goes the integral from, well, y here is actually, I don't know y in terms of x. I know it's 2 sine 2t plus 3 sine t dx from my values of x. You can actually see the values of x are 0 and 4. Okay. The problem here, I have dx, but this is t. So you can't integrate as it stands. So the trick for parametric integration is to kind of very similar to trick to when you're doing the chain rule and connecting different variables like volume and area and rates of change. I'm going to replace this dx with dx by dt. Okay, I know to do that because I know I need it to be dt on the end, right? Because this is t. And I need it to match the previous line. I can't go changing what it is. It's still area. So I still have the dx, and I divide by the dt, and then multiply by the dt. So on the one hand, it's still just the integral of y dx, because the dt's will cancel. On the other hand, dx by dt is an expression I have also in terms of t. Right? Look over here on the definition. X is 8 sine squared t. You can just differentiate. I have x in terms of t, I can find dx by dt. So sine squared t will go to 2 sine t cos t using the chain rule. So dx by dt will be 16 sine t cos t. So I can put it in here. And now this works because I have an integral where the inside is all in terms of t, and I have dt on the outside. So just the formula we come up with, which you can just write down in the exam, the area is going to be the integral of y dx by dt. That's your formula for area for parametric integration. There is actually one other difference, and that's the bounds, right, or the limits, whatever you call them. So before, in my example, I went from x equals 1 to x equals 4. Here we go from x equals 0 to x equals 4. But because I am integrating with respect to t, I need the corresponding values of t. So I need to know at this point in the curve, what does t equal? And at this point in the curve, what does t equal? Now we know t is between 0 and pi by 2. And x is 8 sine squared t. So at this point here, at the end of the region, I know that x is equal to 4. Right? So 8 sine squared t is equal to 4. If you just go and solve this equation for t, you can get sine t divided by the 8 and then square root. And just writing down the solutions in between 0 and pi by 2, there's actually only one of them. Sine t equals root 2 over 2 will give you t equals pi by 4. And sine t equals negative root 2 over 2, there's not any solutions in the range. So at this point, t has to be pi by 4. At this point over here, the origin, x is equal to 0. So 8 sine squared t equals 0. This is going to lead you to t equals 0. Okay? So I'm actually integrating from t equals 0 to t equals pi by 4. Okay. Right, so now I've got my kind of expression. It's an integral into the t. I'm being asked to show that it is an integral into the t and sine and cos. So I'm almost there. We're just going to need to do a little bit of trig identity to match what we have to what was required to show in the question. Okay. And I could obviously just tell you what to do, but I want to kind of show you how you would figure out what to do and what trig, substitutions and identities to use, because you need to be able to figure out yourself in the exam. Okay, so I'm going from 0 to pi by 4. Looking at what I have, or what I'm aiming for, I do notice this 48 sine squared t cos t. And I'm thinking about this here. Your first thought might be to expand the brackets, and that's actually very good, right? 3 sine t times 6 sine t, times 16 sine t cos t, that will give me my 48 sine squared t cos t. So expanding the brackets here is a good step to make. It's going to get me at least part way to the solution. To expand this also out, the first term is going to be 32 sine 2t sine t cos t. Second term will be my required 48 sine squared t cos t dt. Right, great. What do I have left? I have left this 32 sine 2t sine t cos t. That needs to somehow match this expression here, 8 minus 8 cos 4t. And one big clue for how to get there is to look what we call the argument. That's what's inside the sine or the cos. So in the final answer I'm aiming for, the argument is 4t. So I've got cos 4t. And what I have so far, well, sometimes I've got a 2t, and sometimes I've just got a t. So I need to build up this t's and 2t's up to a 4t, which is a suggestion I'm going to use either a double angle formula or some like angle addition formula. And the double angle is going to be good here. And if you think about your double angle formulas, what you have that sine 2t is 2 sine t cos t. And the cos 2t is actually 3 different versions, right? You do need to know all of these. It's going to be very helpful in integration. So you have 2 cos squared t take away 1, or you have 1 take away 2 sine squared t. So I'm going to write those down as well. And looking at what I have in blue on the right here, I do have a sine t cos t. And then a sine t cos t here. So I can build that up to make it a sine 2t. So that's going part of the way towards 4t, right? So 2 sine t cos t makes me sine 2t. I have 32 sine t cos t. That's going to make me 16 sine 2t. I'm going to have 16. This is my first sine 2t here. And then the sine t cos t gives me my other sine 2t. Okay. And the rest of it's just the same. Not changing it. Okay, so now I have the integral of 16 sine squared 2t plus all this stuff still. I'm aiming for something with cos 4t, bear in mind. Then we'll look at my double angle formulas again. Do I have a formula that will relate me a sine squared into a cos? And I do actually. I have this one. Sine squared t will become cos 2t. So over here, when I have sine squared 2t, that's going to give me cos 4t. That's exactly what I need. This is actually always how you would integrate. Whenever you're integrating sine squared t or cos squared t, you always need to use these cos double angle formulas. Okay, that's the trick. So we're going to see the example with integrating sine squared, but cos squared is very similar. So integrating sine squared, I'm going to use this version. I'm going to rearrange for sine squared. So sine squared t is going to be 1 minus cos 2t over 2. So 16 sine squared 2t. Where the 16 is going to turn into an 8 because I'm halving. And because I have 2t here, I'm going to end up with 4t over there. So 8 times 1 minus cos 4t plus blah, blah, blah. And this is going to give me exactly what I need. The final answer, area equal to the integral of 8 minus 8 cos 4t, plus I'll write it in now since it's my last line, 48 sine squared t cos t, dt, and that is the answer, right, as required. Okay, so I've done part A. Part B, which you could have done without being able to do part A, so exam technique, using algebraic integration, find the area, and we know the area is this, so we just need to do this integral now. You could have done the whole thing, obviously, if you couldn't do part A, because you need to know this, but you could have done a good chunk of it at least. So part B is just actually evaluating this integral. Okay, so let's see. Well, how do I integrate this? The 8 and the 8 cos 4t should be pretty straightforward. So I'm going to split it up. 8 minus 8 cos 4t, those are both standard functions to integrate. And this one, I've separated it out. If you're very good, you won't need to. But I separate it out because this one's a little bit more tricky. Okay. So let's do the first one first. So 8 integrates to 8t. 8 cos 4t will come to 8 sine 4t over 4. And there's a minus sign as well. And divide by 4 by this sort of reverse chain rule, or f of ax plus b sort of idea. Okay, now, you might just know this, so you can skip a minute or so, but if you don't know how to do this one, you could try a few different things. You might try writing sine squared as 1 minus cos squared. Not very helpful because you end up with a cos cubed. It is actually going to be a reverse chain rule. And I did a video saying how if you're really uncomfortable with reverse chain rule, you can always do it as a substitution instead. So if you're going to try this with reverse chain rule, fine. If you want to see how to do it with substitution, well, the idea is that sine is like a function, and the derivative of sine is cos, and that's multiplied here. So if you set u to be sine t and do a substitution, you always end up dividing through by this derivative, which will cancel off this cos. I'll flash up the video I have on that if you want to see like more examples of how you can do reverse chain rule without actually doing the reverse chain rule. So here I'm going to write dt equals du over cos t. So this becomes the integral. I will have to change my bounds. So u is sine t. So sine of 0 is 0, and sine of pi by 4 is root 2 over 2. I have 48. Sine is u, so that's u squared. Cos t. dt is du over cos t. They cancel off. Should just be able to do this now. So let's do this bit on the left. 8 times pi by 4 be 2 pi. This is 2 sine 4t. Now, sine of 4 times pi by 4 is sine of pi, and sine of pi is 0. And then t equals 0 into the expression, also just give me 0 for both cases. Sine of 0 is 0. Plus, now this is just 48u squared. We can just integrate that, right? 48u squared is going to integrate to 16u cubed. Increase the power, divide by the new power. 2 over 2 to 0. 2 pi plus, and now let's just drop it a calculator. Show that you substitute it in still. You show that you know what you're doing. So 16 times root 2 over 2 cubed minus 16 times 0 cubed. This stage, just put it in the calculator. The root 2 over 2 cubed, that's going to be 2 root 2. No, it's not. What I think. It's going to be 2 root 2 divided by 8. So it's going to be root 2 over 4. Right? 2 root 2. Yeah, root 2 over 4. So that's going to get 4 root 2. And then that should be final answer. Okay, let's scroll up, just check I haven't missed anything. Find the exact area of R. This seems pretty exact to me. What I would do now in exam, because your calculators can do integration, I would type in this expression we started with, the integral of this thing in red over here. Check in the calculator. Okay, it won't give you it in terms of pi, most likely. It'll give you a decimal. And then what you need to do is just type this into your calculator. and see if you get that same decimal. And if you do, you know you've done it right. If you don't, you've gone wrong somewhere. Okay. So I hope that's helpful. That's parametric integration. Just using this formula in green over here. That's the one you need to know. And yeah, let me know any questions. And I think next time we'll be doing some mechanics.